let's come back and see the next concept. That is, we've already seen the hydrides. We've also seen one question based on that, which is more acidic in nature. So as the size increases, it's easy to release a H plus, and down the group, the acidic character increases. Done. Now when I come back to reactivity with oxygen, basically group 16 elements are going to form oxides of type MO2 and MO3. These are quite common oxide forms. Now M is your the element of group 16, and this is your oxygen combination with O2 and O3. Now here I listed out few oxides, that is not few, rather all the oxides of group 16. This will be useful for your exams also. Let's see. So here sulfur, selenium, tellurium and polonium. Done. Now here I said it's going to form common things are dioxides and trioxides. These two are acidic in nature. I'll explain you the question also. Now see, monoxides, this is your monooxide, means single oxide, oxygen atom. So selenium does not form, tellurium forms, polonium forms. When I take two dioxides, so oxygen is 2 atoms, sulfur and SO2. Dioxide form, dioxide form, dioxide, all form dioxides. When I form trioxides, trioxides are 3 oxygen atoms, so everything forms trioxides. Now when I have to come to heptaoxides, hepta means 7. 7 oxygen atoms. Sulfur is only compound which forms S2O7. They may ask you one more question, what is the only oxide form for like shown by group 16 element? So that is heptaoxide form shown by 16 element, that is S2O7, that is by sulfur. When I have to come back to other types of oxides, remaining, this is the maximum, this is what the elements show. But sulfur, apart from mono, di and tri and hepta, it is also going to show oxides like S2O, S2O3 and SO4. So basically there's one important question asked from this. Let's come back and do that question.